the clear zone and the distance and the recoverable areas illustrates that the clear zone concept in the context of the roadside recovery zone on this slide. Recoverable slopes are those on which a driver may, to a greater or lesser extent, retain and regain control of the vehicle. And non-recoverable slopes that be transversable, but a vehicle will continue to the bottom. A clear run-out area is located at the toe of a non-recoverable slope and is available for safe use by an errant vehicle. There is also provision for a smooth transition between slopes to allow the safe passage of vehicle. The most desirable action of dealing with roadside hazards is to remove or relocate them, although this is not always possible to a road reservation or economic constraints. Where hazards cannot be relocated, then they should either be protected or made more forgiving. It is becoming increasingly common for light poles and signposts to be provided for its fragile bases. This is an attempt to provide a forgiving roadside while still providing the necessary roadside furniture. Common type of poles include slip-based poles, impact-absorbent poles, steel fragile posts, aluminium fragile assemblies, and wooden fragile posts. To support connection of a slip-based pole shears on impact with the pole landing close to the point of impact. Impact-absorbent poles crumbles and bend around the vehicle. Slip-based poles can usually be reused after an impact and for this reason tend to be more common. However, they can only be used where there will be a conflict with the overhead services. There is no conflict with overhead services in the event of the impact and where the risk to other road users, particularly pedestrian, is minimized. Steel fragile posts fold on impact as a result of shear failure planes. Aluminium assemblies collapse due to the shear pin action. Fragile wooden signposts have holes drilled at the base, creating a plane of weakness that permits the post to collapse on impact. Other measures to make roadside hazards more forgiving include considerable the mature trunk size of trees prior to planting, avoiding horizontal fence railing to reduce the risk of spearing, installing drivable culverts and walls. Safety barriers are used to protect hazards that cannot be relocated or made more forgiving. The barriers itself is a hazard and accordingly should only be used when it is less a safety concern than the hazard you as a designer is trying to protect. The three main types of barriers used throughout Australia and New Zealand are concrete safety barriers, guardrails, and wire ropes barriers. So the guardrails and the concrete safety barriers or New Jersey barriers that typically install in the central median as it's shown in a full profile, okay, shown on this slide. Crash cushion systems are also used to protect hazards in confined locations such as a junction of concrete barrier at ramp nose. Concrete safety barriers are best suited to situations where there is a little room between the barrier and the hazard. Typically, this occurs at narrow medians or in areas of restricted road cross-section. The greatest concern with the concrete barriers is the method of termination. Available option, using a steel guardrail terminal assembly to protect the end of the concrete barrier in association with a bridge approach assembly. protecting the barrier with an impact attenuator or crash cushion system. Site characteristics will determine the most appropriate type of attenuation to be used. Concrete safety barriers should be considered on high volume major urban roads as they retain full functionality after impact, provide excellent whole of life cost, and minimize the risk to maintenance workers as maintenance is minimal after the impact. Steel guardrail is perhaps the most common barriers as shown on my sketch and is used extensively in urban environment. The effectiveness of the guardrail is dependent on its length and offset from the main carriageway. The guardrail termination is also a concern, and standards are continually developing to improve end terminals. Most road traffic authorities have detailed guidelines on installation of the guardrails and end terminals. Care should be taken in meeting these requirements. The impact of behavior of the guardrail in terminals should also be considered to ensure that the selected system is appropriate for the intended location. It's worthwhile to mention another type of barriers, wire rope barriers. The wire rope barrier works through the high tension cables. An errant vehicle knocks out the supporting post and the rope deflects with the vehicle before directing it back towards the direction of traffic. Curb and channels should not be placed in front of the safety barrier. The curb and channel is essential. The back of the curb and channel should be located at least 3 meters from the face of concrete safety barrier for all curb types. At least 3 meters from guardrail barrier or wire rope safety system for barrier curbs, and between 0 or 1 meter or at least 3 meters from guardrail barriers or wire rope safety barriers for semi-mountable curb. You don't need to remember these figures, but it's good to familiarize yourself while you reading the Austroads guidelines related to the safety. Other areas related to the roadside safety areas include landscaping, lighting, pedestrian and cyclists, and temporary works during construction. Landscaping. In relation to safety, landscaping on roads, verges, or within the clear zone should not obstruct side distance and be fragile. It is common for medians to be landscaped to reduce headlight glare from opposing traffic. Generally, trees with a mature trunk diameter less than 100 millimeters are considered to be frangible. It is recommended that trees with small trunk diameters less than 100 millimeter diameters should be used for medians and borders, while for traffic islands, for lower level vegetation or trees with a higher canopies are appropriate. Provision for adequate side distance for all road users must be considered, as mentioned throughout my lectures and as shown on my slides. The designer must consider the balance between the streetscape and a road safety objective. The benefits of a high level of street lighting, especially at the urban intersections, are well documented with a strong correlation to nighttime accidents reduction. Street lighting should be substantial enough to provide the driver with a clear view of the road alignment in the urban area. Beside absolute lighting level, it is important to consider consistency and avoidance of dark patches. It will be a matter for each road agency to determine the extent of lighting provision of major urban roads. Where freeways intersect with the major urban roads, it should be common to provide for appropriate lighting of the intersections and access. In relation to pedestrians and cyclists, in design of safe road environment consideration must also be given to non-vehicular road users. The needs of pedestrians, including those with disabilities and cyclists, discussed in various guidelines. The safety issues to be addressed for on-road cyclists are very similar to those relating to motor vehicles. It is important for road surface to be smooth, to minimize conflicts, and to provide appropriate delineation. Consideration should be given to the provision of an exclusive bike lanes and to the treatment of determination of bike lanes. Pedestrian safety relates to a number of controlled crossing points and the provision of footpasses close to the traffic lanes. It is desirable for footpasses to be set back from the curbs to provide protection for pedestrians from errant vehicles. Local specific guidelines should be used to determine the provision or crossing facilities. Construction and maintenance operations should not inhibit traffic, and where possible, separation should be provided through the diversion routes. Some studies have identified high accident rates through the work zones where proper warning and delineation has not been achieved. In reality, there is always be a requirement for some traffic movement through work zones on existing major urban roads. Where this is necessary, clear and positive guidelines, guidance approaching and through the work zones is a crucial element in overall safety of the site. I have provided you with fundamental considerations of the road design, fundamental principles for road design, and now I'll provide you with a quick overview on the road design software that are available for producing road design. The software and the authors of the software obviously learned the road design principles, design inputs, design considerations, and incorporated them in a range of the road design software that are available in the market. I have tried to capture the most commonly used software, but I want to specifically mention that majority of the road design in Australia using the Bentley InRoad software and Bentley MX Roads. It's needless to say that all other software are basically competing with Bentley systems, and it all comes down to the number of features it has, accuracy of producing the different road elements. These models are able to produce three-dimensional design, two-dimensional design, and all road geometry.